Welcome back. Blockchain could help us bring about this next generation of the web. But how? What exactly is blockchain? Let's dive straight in. Blockchain is, it's a chain of blocks. This chain of blocks forms a database. Each block is a record in the database that stores some data. These blocks are linked together using cryptography to keep the database secure. Let's break it down by looking at a single block. It'll be made up of three main things. We have some data that's stored in the block. For now, let's just say it's data on popcorn. Alongside this data, we would have a hash of the current block that uniquely identifies the block and everything it contains. The hash is a string of letters and numbers that acts like a fingerprint. Just like a person's fingerprint is unique only to them, a hash is unique for every possible block. If we change the data to, say, ice cream, the hash of our block will change as well. Because of this feature, hashes are a very useful tool for detecting if something has changed. Finally, we have the hash of the previous block, or the fingerprint of the block that was added to the blockchain immediately before the current block. It's this previous hash here that creates the link between blocks that forms a chain. Let's take a look at an example. Say we have a blockchain with just 3 blocks. Each of these blocks, as expected, has a unique hash. In the example here, I'm using these shortened, abbreviated hashes to keep things simple. So we have 3 blocks, each with a unique hash, and a link to a previous block, using a hash which points to that block. Now, the first block here is special. It came before all the others, so it doesn't have a previous hash. In blockchain, this is what is known as the genesis block, the one that starts the whole chain. Now notice that the links between blocks are created by having the previous hash of the second block here point to the hash of the first block. And it's the same for the 2 other blocks. The beauty of this approach is that now, if a hacker tries to go into the blockchain and change the data in one of the blocks here, when the block changes, the hash here will also change. Now, the link with all of the later blocks will be broken because the previous hash no longer matches the hash of the hacked block. The consequence of tampering with just one block means that all of the blocks after it are invalid. The chain has been broken. Now, this might not seem like the best behavior. We don't want hackers to be able to break the entire blockchain, right? We'll see why this is in fact a feature and not a bug in the next video. But first, let's recap. So, blockchain is a database, but it's a database that has some special rules. Just like any database, we can read existing blocks and make use of the data they contain. We can add new blocks and connect them with the chain, but we can't update existing blocks. That's not allowed. This is a property of the blockchain known as immutability. Once a piece of data is on the blockchain, it's there forever. You could later add some new data in another block that changes the current state of your data, but the original will always stick around. Now, because part of what our blocks contain is the hash of the previous block, immutability means that we can't remove blocks from the blockchain either. Say we wanted to remove this third block. Because the fourth block is immutable, we can't change the previous hash that it points to, which means the blockchain will always expect that third block to be in the chain, exactly like when it was originally added. That's immutability. And it's how we use these hashes from the world of cryptography to create a chain of blocks. There we go. Finally, we have a picture of how the blockchain actually looks. In the next video, let's explore the other key feature of blockchain, the fact that it's distributed. After that, we'll be able to look at some really cool applications of this technology. It'll be a good one, so I'll see you there.